All right, year 9, F and G bring us to the end of our chapter 7. And F and G introduces, well, or revises really what scientific notation is. And then it also brings in your significant figures, which you first looked at in video 1C at the beginning of the year. So if you'd really like to look a little bit more on significant figures, go back to 1C, which all the videos are on YouTube. So scientific notation, when you write it in terms with positive indices, now that we understand indices a little bit better, scientific notation makes a bit more sense. So for example, if I wanted to write the number 5, let's go with 5 million, all right? That's a lot of zeros to write out. And now that I know indices, what I really know is that this first position is our units, and then our tens, all right, and then our hundreds. So every additional digit that we add into a number, we basically are adding another base 10. So this first one, our units, is 10 to the 0 power. Remember that everything to the 0 power is 1. The second place is our tens. So it's 10 times 10 to the first power. And then our hundreds is 10 to the second. And that continues for however large we make this number, if we have positive indices. So I'm going to write 5 million as 5 times 10, and then depending on how many places I've got or how many zeros I have, that will become my index. So I've got 1, 2, 3, 4, 5, 6. So 5 times 10 to the 6th power means I'm going to take 6 additional zeros, or I'm going to add 6 additional places after the 5 to make my actual number. So it's a little shorter way of writing 5 million, 5 times 10 to the 6th. If you have negative indices, now we're talking about a very small number, because remember, negative indices represent a fraction. So if I were going to write 0.000000006, oh my goodness, we're talking about this first position is a tenth, which is 1 over 10. Second position is a hundredth, which is 1 over 100, or 1 over 10 squared. And this continues. So remember, when we have a fraction, or our 10 is in the denominator, it means we have a negative index. So I'm going to use the 6 as my starting point. And I'm going to say, well, how many zeros are in front of the 6? So 1, 2, 3, 4, 5, 6, 7. So really, that means I'm going to have 6 over, let's see, 1, 2, 3, 4, 5, 6, 7. What position is that? We've got 10th, 100th, 1,000th, 10,000, 100,000, and we have our million, 10 million, 100 million. So we're really talking about a very, very, very small number, 100 millionth. So I've got to talk about negative 7 as how many zeros I'm going to move to the left. So the negative tells me I'm going to move my decimal from in front of the 6, behind the 6, 1, 2, 3, 4, 5, 6, 7. Oh boy, I've got to use one more to get to where I want my decimal to be. So not only is it how many zeros are there, but it's plus this one additional digit of the 6. So I'm going to change my 7 to a 8, because that tells me I'm not just moving the amount of zeros, but I have one additional position to move it, because I'm also including the position of my non-zero digit. So I'm taking my decimal from in front of this, or behind the 6, 1, 2, 3, 4, 5, 6, 7, 8. I'm moving it 8 times to the left. So I'm going to take the number of zeros I have, or placeholders, plus the additional position of my non-zero digit. So anytime that we look at scientific notation, we have a non-zero digit, and then we multiply by 10 to some power. If it's a positive power, that means it's the number of zeros or the number of places I'm moving to the right. So for my first example, it was 1, 2, 3, 4, 5, 6 positions to the right. If it's a negative number, that means I'm taking my decimal and moving it left. Okay, and my decimal is always after my non-zero digit, because that would let me represent it as a whole number, as a unit. All right, so let me take a look down here. Do we remember what a significant figure is? So this is just a revision from our chapter 1. Any captive zeros that are between non-zero numbers, like these two zeros, are considered significant. Any zeros that are after non-zero numbers, but there's a decimal, so these three right here, those are considered significant. But if you have zeros after non-zero numbers and there is no decimal, then these are not considered significant. Also, if you have any zeros that are just placeholders, they're before you begin your non-zero number, those are also not significant. All right, so some of the directions might say to leave your answer with a certain number of significant figures. So we're going to bring back our chapter 1 revision with this chapter as well. So for our first example, we're going to write 4,500,000 in scientific notation. So I'm going to look at where my first non-zero digit is, and I'm going to put my decimal directly after it. So 4.5 times, how many places would I have to move to the right in order to get my decimal where it belongs, which is at the end of all these zeros? So I'm going to say times 10 to 1, 2, 3, 4, 5, 6 power. Because it's positive, that means I'm going to move to the right. So I'm going to take this original decimal, move it 1, 2, 3, 4, 5, 6 places to the right, and then I would have 4,500,000. So the way to write it in scientific notation is 4.5 times 10 to the 6th. For our second example, we're going to write 0.000004 in scientific notation. So again, I'm going to go to my first non-zeroed number, and I put my decimal directly after it. So 4 times 10. I need to move left in order to get my decimal back to where the question asked me to put it. I'm going to move left 1, 2, 3, 4, 5, 6, 7 times. And because I'm moving left, I use -7. So remember, there are 1, 2, 3, 4, 5, 6 zeros plus the additional position of where the 4 is, and that makes me move my decimal 7 times to the left. Example 3 is going to ask us to take scientific notation and write this number as a basic numeral. So I'm actually going in reverse. So times 10 to the 6 means I'm moving to the right, because it's a positive exponent, and I'm going to move this decimal 6 times. So if I have 9.34 written down, and I move my decimal 6 times to the right, there's 1, 2, 3, 4, 5, 6, and I put my new decimal here. Well, then what in the world do I put in this big space? This is where I add in zeros. So there's a 0 in between every one of these little loops. So I can go in between the 3 and 4, in between the 4 and 0, in between these zeros, in between these zeros, and then after the last 0. So just to write this correctly, I have 9, 3, 4, 0, 0, 0, 1, 2, 3, 4 zeros. And then goes my decimal place. So what I'm actually looking at here is 9,340,000, and I've got nothing left at the end there. We'll go ahead and make this our last example. So 4.71 multiplied by 10 to the -6 as a basic numeral, so we want to take it out of scientific notation. The negative means I'm going to move my decimal to the left. So that means I'm going to give myself a little space. 4.71 is what I start with, and I'm going to move left 1, 2, 3, 4, 5, 6 times before I put my decimal down, which means I need a 0 here, 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 and it looks like there as well. 1, 2, 3, 4, 5, 6. Yes. So remember, I have 5 zeros plus the additional space from where my decimal starts. So to clean this up, 0.1, 2, 3, 4, 5, with this 4, 7, 1. All right, so that was tenths hundreds, thousands, 10,000s, 100,000s. Oh boy, millions, 10 millions, 100 millions. So 471 100 millions. See you guys next time.